Today, lesson 45A, word problems and involving solving multi-step equations. So we're about to start a 3-day process of taking everything we know about solving multi-step equations and then applying it to what sometimes are referred to as real-world problems. I prefer word problems, but they both represent the same ideas. So our big focus is on setting up the correct equation and then from there solving it, but not only that, from there answering the question that we're being asked. So a little bit of background knowledge. Here's what we worked on yesterday. When we're talking about multi-step equations, we're talking about equations that take typically more than 2 steps to solve. And here was one from yesterday's lesson. Here was another one from before I get to that, what does it mean to justify? If you're asked to justify or give justification, what does that mean? Yeah. Show the properties. What does it mean to check? What does that mean?
Substitute the value of the variable
back into the original equation, right? And if it makes a true statement, you know that your solution is correct. If it doesn't, that means you need to go back to work. And same thing here. Here we had to use the distributive property, then combine like terms. And then after we did that, we had a 2-step equation. And sometimes we are asked to justify and check, sometimes we're not. All right, let's just go ahead and get started. Mrs. Treble charges her music students $25 per hour plus a recital fee of $50. Each lesson is an hour. How many lessons, or in other words, how many hours did the student take if she paid a total of $175? So the first thing that we need to do is come up with some sort of an equation that would represent the situation. Well, I'm going to start each different type of problem today with a sort of guessing and checking strategy, just so we can sort of figure out what this thing is going to look like. So it does state within the problem that that she charges $25 per hour, in other words, $25 per lesson, plus a $50 recital fee. So if somebody took one lesson, that total cost would come from 25 times 1. In other words, 1 hour times the $25 plus the $50 recital fee. Well, that would be $75. If they took 2 lessons, that would, of course, be 25 times 2 plus 50, and that's $100. But we're trying to figure out how many lessons she took to have a total of $175. Well, if I kept going with this guess and check strategy, it should be very clear to you the part that is changing. And finally, I get there. But to be perfectly honest with you, I wouldn't want to have to guess and check every single time, because let's just say that they took 172 lessons. You know, it'd take you a long time to figure that out. So if we focus on that part right there, that's the part that is changing every single time when I'm guessing and checking. That means that the number of hours is variable, or the number of lessons is variable. And variable means, in English, something that is changing. And that's where the whole concept of a variable or letter comes from. A letter represents something that is changing. So that should become very clear to us that means the equation for this problem would look something like this. 25x plus 50 equals 175. Because it is the multiplication of, or by 25, that is the part that is changing. And then from there, we have a nice, easy, in this case, 2-step equation to solve. 25x plus 50, and I'm kind of highlighting how you can sort of pick out those pieces without guessing and checking every single time, and to make a total of 175. So I would subtract 50 from both sides, and then of course divide both sides by 25, and I get x equals 5. But we're not supposed to stop there, because if we're asked to solve an equation, we're stopping there because that's the solution, but we have not answered the question. And the question here is, how many lessons did the student take? Well, every time we solve a word problem, and we've been sort of hinting at this as we've gone through problems here in this first trimester, we need to make sure we write our answer as a complete sentence. So just make sure that you have a sentence that represents what I have written. The student took 5 lessons. Doesn't have to say that exactly, but it has to say something that resembles that. By the way, is 5 lessons a complete sentence?
No.
No, it's not. Something like the student took 5 lessons. Okay, so before I have you try number 2, I started this with some sort of guess and check strategy to show you what part was changing to make it clear where the variable is supposed to go. But what we have to get very good at is looking within the problem and start sort of figuring out where the variable should be and where other parts of the word problem should be. So for example, one little tip is look for words like per or for each or for every or other words that could mean the same thing, because that's most of the time that tells you kind of where the variable is supposed to go. The total will always be on its own on one side of your equation. And usually also what you're trying to find, usually that will tell you also where x is supposed to go. And in this problem we're supposed to find how many lessons, which a lesson is an hour. And so that's another way of figuring out that the variable should go with the 25. Lots of ways of kind of figuring that out. We're asked to find how many lessons, and each lesson is an hour, so that's another way of thinking about it. Okay? All right, everybody take a look at number 2. Set up an equation and solve. Or as the instructions say, write the following word problem as an equation and solve. All right, I would like all of you to compare with your shoulder partner. First, the equation you came up with. Second, the solution to the equation. And then the sentence that you have written that actually answers the question, and make sure it's a complete sentence. Go. Number 2, Sam is planning a vacation. He already has $180. What we're going to, when we hit another set of topics here in another 2 units, we will be referring to that as the initial value. But he has $180 and he's saving $45 each week. And as soon as I see that, I'm starting to think that's probably where the variable is going to go. If I look at what I'm being asked to find, which is how many weeks, that makes it clear to me that that's where that variable is supposed to go. And that's because it's that part that is changing. After 1 week, it's 45 times 1 plus 180. After 2, it's 45 times 2 plus 180, and so on. And we have a total here of $900. So our equation would look something like this. We subtract 180 from both sides, then divide both sides by 45. We all know the reasons why. And we end up with x equals 16, but I have not answered the question yet. The question is, how many weeks will it take him to save for the trip? Make sure you write as a complete sentence, it took Sam 16 weeks. All right, everybody try. Number 3. All right, Carmela wants to buy a digital camera for $192.50. She has $24.75 already, so that's the initial value, and is saving $15.25 each week. And how many weeks will she have enough money saved to purchase the camera? Highlighting important pieces of information, the $15.25 each week, that to me tells me that that's probably where the variable is going to go. And if I look to see what I'm being asked to find in how many weeks, that makes it clear that that's where it's supposed to go. And we have a total of $192.50. My equation looks something like this. And so we subtract 24.75 from both sides, then divide both sides by 15.25, and we get, as a solution to that equation, 11. But we need to answer the question as a complete sentence, and it could look something like this. It took her 11 weeks to save up for the camera. All right, so everybody try number 4. Okay, so I think that there's a typo in the first sentence that's probably supposed to say something other than a week. So let's just pretend like a week is not there, that it's something else. But here's the deal, and I noticed that most of you had no problems with this. I think you were maybe not quite sure if you were doing the right thing because it didn't come out even. But a couple of you were trying to do this without an equation. It's very clear in the instructions. Write the following word problem as an equation and solve. That's what we need to be doing. And the first thing you need to figure out is where the variable should be going. And if I thought about this in terms of just guess and check, for one day, it says it rained 2/3 of an inch each day after that. So the second day after that, oops, it would be something like this. And then that's the next day after that. The expression would look something like this because it initially rained 0.5 inches, and then every day after that it was 2/3 of an inch each day. So it should be very clear to you this is where the variable needs to be. Even if you didn't see it here and here, because that should clear it up, 2/3 of an inch each day for how many more days? So whatever it takes to get you to understand where that variable is supposed to be, you need to get that figured out. And so the equation should look like this. 2/3 x plus 0.5 equals 10. We have an issue here with the 2/3 and the 0.5. Do we want to convert the 2/3 to a decimal, yes or no? No, that becomes a problem because of the fact that it's a repeating decimal. So I'm going to go ahead and instead of rewriting it, I'm just going to subtract 1/2 from both sides because that's the fractional equivalent to 0.5. And from there I have 2/3 x equals 9.5. Divide both sides by 2/3 and we get 14.25 for the solution to the equation. As a sentence, it rained for 14.25 more days. All right, so that's idea number 1 for today. Idea number 2 is where we truly do have a multi-step equation. So let's take a look at number 5. And we're going to start with a nice, easy problem, and I'm very aware everybody in here could figure that out in their head if I gave them a minute to do it, but that's not the point. We start off with easy problems so that when we get to more difficult problems, we know how to deal with them. So the sum of two numbers is 180. One number is 18 bigger than the other. What are the two numbers? Well, I'm going to start this one the same way I started number 1, and that's with some sort of a guess and check strategy so we can figure out where the variable or variables are supposed to be. So we know that the sum of two numbers is 180, and we know that one number is 18 bigger than the other. So several questions in situations like this that we should always be asking ourselves are questions like this. How many things are we trying to find? Well, in this problem, how many things are we trying to find? That's not a trick question. How many? Two. We're trying to find two numbers, so two things. So number 1 and number 2. And the next question we should be asking is, what are we doing to find the answer? In other words, are we adding, are we subtracting, are we multiplying, are we dividing? What are we doing? That's not a trick question either. Which one are we doing? Adding, subtracting, multiplying, or dividing? Wow, that's not very convincing. How do you know that you're adding? By adding. It says the sum. Thank you. That's what I'm looking for. The sum. That tells you that we need to add. And we're trying to make a total of 180. So if I just guessed with the number 10, for example, if the first number is 10, what would the second number be then? 28, right? 10 plus 18. That's how I got 28. And if we add those together, we can see that that's not going to be big enough and work for the 180 that we're trying to make there. And so now I'll guess 11. And once again, the whole point of what I'm trying to do here is I'm trying to show you what part is the variable. And that's still too small. So then I could go up to 12 and so on. But it should be clear to you right now where the variables have to go. And remember, a variable is where something is changing. So right here and right here, but those are both the same thing. So that should tell us that's where our variable needs to go. So that leads us to x for the first number, because I don't know what it is. That's what I'm trying to find. And the only thing I know about the other number is that it's 18 bigger than x. And 18 bigger than x is x plus 18. And that was the point of what I was trying to show you in that previous slide. 10 plus 10 plus 18. 11 plus 11 plus 18. 12 plus 12 plus 18. And we know now that we're supposed to add both of those expressions together. That's why I asked that question. And we know that the total of those two numbers is supposed to be 180. So that makes the equation for this problem x plus 18 equals 180. Now this is a multi-step equation because it's going to take more than two steps. So we would have to combine like terms. Now we have a two-step equation. So we of course subtract 18 from both sides. Then divide both sides by 2 and we get x equals 81. But once again we have to answer the question. X equals 81. So what? What does that mean? Turn to your shoulder partner. Have a quick discussion. What does that mean? So we took an equation, we solved it for x. Once again, so what? What does that mean in the context of this problem?
We substitute x for 81
Okay.
to get the second number.
So 81 is the second number? Which number is 81? Is it the first number or the second number?
First.
Yeah, and here's another reason why we do something like this. The first number is x. So this is the first number. To find the second number, we're of course going to have to add 18 onto that. And so we need to answer our problem as a complete sentence. So the numbers are 81 and 99. Because what we found was the first number. Now, we've come across a problem before where I gave an example that if somebody in this room was 13 years old and somebody else was 11 years old, that there's always two ways of looking at that situation. One would be saying that the person who's older is 2 years older, but we could flip that and say that the person who's younger is 2 years younger. Both of those situations represent the same idea. So what if you thought that the second number was the smaller one instead? So there's a different way of setting this up so that we would come up with the same idea. Now, having said that, I like to do these kind of problems by thinking of the smallest thing first. But what if you didn't do that? Here's what it would look like. If we thought of the second number as being the bigger number, then what that would mean is that the first number would be x minus 18, right? In the first way we did it, the second number was 18 bigger than the first number. This way, the first number is 18 smaller than the second number. So there's always going to be multiple ways of coming up with an equation for these types of problems, okay? So I just want to make that clear. All right, everybody try number 6. Eric is 9 years older than Barry. The sum of their ages is 31. How old are Eric and Barry? Well, I'm going to ask those same questions over and over and over again. How many things are we trying to find? How many? 2. Eric's age and Barry's age. I'm going to list Barry first because I like to pick the smallest thing or put the smallest thing, or in this case, the smallest age first. Barry is younger than Eric is, so I'm going to list Barry first. And then what are we going to do with those two ages? Add, subtract, multiply, or divide? Add them together because the sum of their ages is 31. So Barry is x. Eric is 9 years older than Barry, so that would make Eric x plus 9. And we're supposed to add those two things together to make 31. And there's our equation. And to make it very clear, you know, all this other stuff is just so I have talking points in the lesson. I'm expecting you to just start right there, okay? So we combine like terms, solve the equation, and we get x equals 11. So what? What does x equals 11 mean? What does it mean, Drew?
That's the first number.
Well, we're not looking for numbers this time.
Or that means it's Barry.
That's Barry's age, right? So Barry is 11. Eric is 9 years older than that. So that would make Eric 20. So Barry is 11 and Eric is 20. Okay, I want you to do number 7 and number 8. They're the same exact kind of situations, but I want you to work on them with your shoulder partner. Come up with an equation between the two of you. Then I want you to individually solve the equation and then come up with what the sentences should look like with each of those problems. So do number 7 and number 8 with your shoulder partner. Go. In number 7, a cable 101 meters long is cut into 2 pieces, so that one piece is 33 meters longer than the other cable. This is not really any different than the very first problem we did with the 2 numbers where one was 18 bigger. We're just talking about pieces of a cable instead of numbers. Find the length of each piece of cable. We're trying to find 2 things, piece number 1 and piece number 2. I like to think of the smallest thing first. So that usually will make the problem easier. So if piece number 1 is x, piece number 2 would be 33 longer than that, so it would be x plus 33. We're supposed to add those 2 pieces together to find the total length. So that gives me an equation of x plus 33 equals 101. Combine like terms, subtract 33, divide by 2. We get x equals 32, or excuse me, x equals 34. And x is the first piece. So piece number 1, or the first piece, is 34 meters. Don't forget to label. And the other piece is 33 longer than that, so it would be 67 meters. In number 8, the sum of 3 numbers is 50. The second number is 4 times the first, and the third is 2 more than the first. Once again, I like to think of the smallest thing, or in this case, the smallest number first. And we're supposed to add all of those things together. So if the first number is x, the second one, it says in the second sentence that the second number is 4 times the first. So that would be 4x. 4x means 4 times x. And the third is 2 more than the first. Remember, the first one is x, so 2 more than that would be x plus 2. We're supposed to add all of those things together to make 50. Combine like terms, which gives us 6x plus 2 equals 50. So subtract 2 from both sides, divide by 6, and we get x equals 8. 8 is x, and that's the first number. So the first number is 8. The second number is 4 times that, which would be 32. And the third number is 2 more than that, which would be 10. So the numbers are 8, 32, and 10. Any questions about number 7 or number 8? Okay, so then that leads us to our last idea for today, and that would be problems where we're dealing with the perimeter of a rectangle. By the way, how do you find the perimeter of a rectangle? How do you find? Adding up all the sides. How many sides does a rectangle have?
4.
You need to keep that in mind for this last bunch of problems. The width of a rectangle is 9 more than the length. If the perimeter is 50, find the width and the length. Now, if we're thinking about this in terms of the other problems, the biggest mistake is thinking about, well, I'm only finding 2 things. Well, technically, you are only finding 2 things, but there are 2 of each of those things. Which one is smaller, the width or the length? The width is smaller?
Yeah.
The width of a rectangle is 9 more than the length. You want to try that again? Which one is smaller, the length or the width? The length is smaller. So I want to think of that first. So we have 2 lengths and 2 widths. Because remember, to find the perimeter, you're adding up 4 sides. So that means the lengths are smaller, so they would each be represented by x. The width is 9 more than that, so each of the widths would be x plus 9. And this is a commonly missed type of problem. Too many people will just say, oh, x plus 9 equals 50. Well, if you did that, you only added up 2 of the 4 sides. Or you're trying to find 2 of it. You're supposed to find all 4 of them. So we combine like terms. And we're supposed to make a total of 50 there. And then we would, of course, subtract 18 from both sides. And divide both sides by 4. And we get x equals 8. Well, 8 is the length. So that means the length is 8 because the length is represented by x. And that makes the width 17 because of the fact that it's 9 more than that. All right, so we're going to finish off today with number 10, 11, and 12. I want you to work on 10, 11, and 12 with your shoulder partner. Set up your equations. compare, and then answer the questions. Okay? Number 10 looks like this. The length of a rectangle is 7 more than the width. If the perimeter is 70, find the width and the length. So we can see with the first sentence that it is actually the width that is smaller, and I like to list the smaller thing first. It doesn't mean you have to, but for many problems it makes it a little easier. Because what that tells me is I'm going to make the width x, and if the length is 7 more than that, then each length would be x plus 7. If you made the length x, then each width would be x minus 7, because remember there's two different ways of looking at that. And so I'm going to add all of the sides together. We're supposed to make 70 there. Combine like terms, solve the equation. I get x equals 8. And 8 is the width. Or excuse me, not 8, it's 14. The width is 14, and the length is 7 more than that, so the length is going to be 21. So the width is 14 and the length is 21. Number 11 looks like this. The width of a rectangle is twice the length. So the length is smaller, so I like to list the length first. And this would be a classic problem where if you made the width x, you're going to make the problem more complicated because then the length would have to be 1/2 x. I like to list the smallest thing first because then we are less likely to have to deal with things like that. So the equation would be x plus 2x plus 2x, and that is supposed to be equal to 96. Combine all of your x's together, and this one actually ends up being easier at that point. So x is 16, which makes the length 16, and the width 32. Now, number 12. The perimeter of a rectangle is 54. The length is 6 feet. What is the width? This one is actually easier. We're trying to only find the width, so we're going to make the width x, and it states within the problem that the length is 6. So we have x plus 6 plus 6, because it says in that second sentence the length is 6 feet. So there is the equation for number 12. Combine like terms, solve the problem, and we get x equals 21. And this time the length is labeled, so we need to make sure we label. So the length is 21, or excuse me, the width is 21 feet. And we are finished for today.